All right, so let's discuss what causes electrons to move, what causes a current to happen. So in a conductor, we know that there are electrons moving around in all different directions. And it's random motion, so there's no net flow one direction or another. But suppose we put a few charges up there. We know the electrons are attracted to positives and repelled by negatives. So let's imagine we put some positives over here to attract the electrons. And we put some negatives on the other side to repel the electrons. Now, overall, this is going to be a small effect compared to the strength of force they feel from their local atoms. And they're still going to do a lot of random motion bouncing around. But with each bounce, they're going to get pushed a little bit away from the negatives and towards the positives. So if you look here at the blue line bounces around and ends up almost exactly where it started. If we take the same exact path, but each time give it a little nudge, pushed away from the negatives, pushed toward the positives, a little nudge each time to the right, we get a much larger net displacement. So there will be a net motion of the electrons away from the negatives towards the positives. Okay, so we have negative charges going right. But that's exactly the same effect as we would see if we had positive charges going away from the positives towards the negatives, that direction. And in either case, we say that this is a current moving to the left, away from the positives towards the negatives. It could be negative charges moving right, it could be positive charges moving left. I like to think of this in terms of an analogy that I call the bar analogy. So let's imagine we have a bunch of pretty young women all sitting at the bar, or all in a nightclub. They don't need to all be in one row. And we have a bunch of handsome, strapping young men. And they're sitting around, conversing with the ladies, doing their best to make a good impression. Now, let's suppose we take a mean, ugly bouncer, and he's going to take one of these guys and take him out. And then maybe he'll take another guy and take him out. Well, these guys are going to start to float around and try and fill in the extra space as best they can. Okay? But they're probably going to move around and mill around to all sorts of different places. And this will just leave us with a slightly more women. In this analogy, the men are the electrons, the women are the protons. All right, well, let's suppose that the bouncer, instead of just taking these men out, puts these men back over here on this side. Oh, well, that's going to influence guys to move over more. Okay. Now, if we continue to take guys out of this side and place them all over here, well, look, these women on the left are getting all the attention. These poor ladies are being left out, so maybe these guys will come on over. Okay. Then if I take another one out, this guy says, oh, well, maybe I have a chance over here. Particularly when I put this guy over here and he feels a little displaced and moves over. Okay. So we can get a large current even in a situation where we might not be able to get them to separate too terribly much. Just a few more comments to make about current. We always define current to be the direction of positive charge flow even if it's the negative charges that are moving. This stems back to Benjamin Franklin defining positive to be the charge on a glass rod rubbed with silk. He had no better way of knowing, and really there's no macroscopic experiment which can tell us one from the other. Macroscopically, this, with all the positives moving to the right, looks exactly like this with all the negatives moving to the left. Okay, current is not a vector. It does have a direction, but it follows along in a wire generally, so we're not going to call it a vector. And there is an electric field inside a current carrying wire, but it's not going to cause these to speed up because the electrons are constantly bouncing into other ions. We'll talk more about that in the next chapter.